Good day, this is Elora Danille Dioquino, and I'm going to discuss about transpiration and evapotranspiration. So, what do we mean by transpiration? So, this is a process of which water vapor leaves the living plant body and enters the atmosphere. So this is the process in which water vapor from the soil is absorbed by plants through the roots and discharged back to the atmosphere through their leaves and through these little pores present in the leaves, which are also known as stomata. So basically this is an evaporation process. Transpiration ratio is the amount of water by a crop in its growth to produce unit weight of dry matter. So next we have is the factors affecting transpiration. Number one, we have the temperature. So the transpiration rates goes up when the temperature goes up, especially during growing season when the air is warmer due to stronger sunlight and warmer air masses. So this high temperature cause the plant cells which control the openings or the stomata where the water is released to the atmosphere to open, whereas colder temperature cause the openings to close. Next is the relative humidity. So relative humidity of the air surrounding the plant rises to transpiration rate falls. It is easier for water to evaporate into drier air than into more saturated air. And next we have is the wind and air movements. Increased movement of the air around the plant will result in a higher transpiration rate. This is somewhat related to the relative humidity of the air in that as water transpires from a leaf, the water saturates the air surrounding the leaf. So if there is no wind, the air around the leaf may not move very much, raising the humidity of the air around the leaf. Wind will move the air around with the result that the more saturated air close to the leaf is replaced by drier air. So next is the soil moisture availability. So when the soil moisture is lacking, plants can begin to sense premature aging, which can cause in leaf loss and transpire less water. Also, another factor is the type of plant. Plant transpires water at different rates. Some plant which grow in an arid region, for example, a cactus and a succulents, they conserve precious water by transpiring less water than other plants. We move on to the measurement of transpiration. One measurement of transpiration is photometer. This is also known as transpirometer. It's a device used for measuring the rate transpiration. So we have the example or the types of photometer, the Ganong's, the Farmer's, and the Darwin's photometer. And we move on to the evapotranspiration. So this is the quality of water transpired by the plants during their growth or retained in plant tissue, plus the moisture evaporated from the surface of the soil and the vegetation. So this is the combined process of evaporation and transpiration and involves the transfer of water to the atmosphere both from water sources and vegetation. So this accounts for the movement of water to the air from sources such as soil, canopy, interception, and water bodies. We move on to the factors affecting evapotranspiration. So one, we have energy availability. So the more energy available, the greater the rate of evapotranspiration. So it takes about 600 calories of heat energy to change 1 gram of liquid water into gas. Next, we have the humidity. The humidity gradient away from the surface. So the rate of quantity of water vapor entering into the atmosphere both become higher in drier air. Also, next factor is the wind speed. So the process of evapotranspiration moves water vapor from ground or water surface to an adjacent shallow layer that is only a few centimeters thick. When this layer becomes saturated, evapotranspiration stops. So, however, wind can remove this layer, replacing it with drier air, which increases the potential for evapotranspiration. Winds also affect evapotranspiration by bringing heat energy into an area. So, wind speed and winds are factors of affecting evapotranspiration. Next, we have the water availability. Evapotranspiration cannot occur if water is not available. And next, we have the physical attributes of vegetation. So, example of this is the plant height, the leaf area index, the leaf shape, and the reflectivity of plant surfaces. So it can affect the rates of evapotranspiration. So for example, coniferous forests and alfalfa fields reflect only about 25% of solar energy, thus retaining substantial thermal energy to promote transpiration. In contrast, deserts reflect as much as 50% of solar energy depending on the density of vegetation. So plants regulate transpiration through adjustment of small openings in the leaves, and these are called stomata. As stomata close, the resistance of the leaf to loss of water vapor increases. So decreases to the diffusion of water vapor from a plant to the atmosphere. And next we have the soil characteristics. So this can also affect the evapotranspiration, and it includes the heat capacity and soil chemistry and albedo. So the estimation of evapotranspiration, you have number one is lysimeter. So this is a device and it is a direct method in which a volume of soil planted with vegetation is located in a container to isolate it hydrologically from surrounding soil. Through this amount, water lost by evapotranspiration can be worked out by calculating the difference between the weight before and after precipitation input. And these are the examples of lysimeter. We have the sampling lysimeter, soil moisture probe lysimeter, weighing lysimeter, and pan lysimeter, and weak lysimeter. So there's no standard on this or recommended lysimeter. An engineer should employ, rather it depends on the application. So with careful planning, design, and implementation, a selection of a correct lysimeter will lead to good result. So next we have is the eddy covariance. This is a fast fluctuation of vertical wind speed are correlated with fast fluctuations in atmospheric water vapor density. So this is also a direct method. It estimates the transfer of water vapor from the land surface to the atmosphere. So this is the example of the eddies covariance. And lastly, we have the open pan evaporimeter. So this is indirect method. So an evaporation pan provides a measurement of combined effect of temperature, humidity, wind speed, and sunshine on the reference graph evapotranspiration. So these are the examples of the open pan evaporimeter. So this works, we have the principle of evaporation pan. The pan is installed in a field like the example here, and the pan is filled with known quantity of water. So the surface area of pan is known and the water depth is measured. So the water is allowed to evaporate during a certain period of time. So it is usually measured usually 24 hours. For example, each morning at 7 o'clock, a measurement is taken. So if the rainfall occurs, this is measured simultaneously. So after 24 hours, the remaining quantity of water So for example, the water depth is measured. The amount of evaporation per time unit is the difference between the two measured water depths is calculated. This is the pan evaporation, so, or the EPAN. So this unit is in millimeter over 24 hours. So the EPAN is multiplied by a pan, so coefficient K pan, to obtain the evapotranspiration. So this is the formula for this last uh, last example. So the reference crop evapotranspiration is equal to the crop coefficient multiplied by the pan evaporation. So that ends my topic. Thank you so much, everyone.